Okay, let's dive straight into this explainer because what we're tracking today is essentially a massive chronological detective story. We are going to unpack a profound vulnerability in artificial intelligence, specifically a fundamental flaw in how AI handles thought suppression. And you know what makes this so incredibly fascinating? This exact vulnerability was discovered twice independently by two completely different entities in the summer of 2026. It's a wild ride that takes us from the absolute bare metal physics of computer chips all the way up to the highest tiers of corporate AI safety research. But before we get totally lost in the complex AI code, I actually want you to try a quick experiment right now in your own brain. Ready? Okay, whatever you do, absolutely do not think of a pink elephant. Seriously, clear your mind entirely and do not picture a pink elephant. Well, what just happened? You instantly pictured one, right? It's impossible not to. This brilliantly illustrates the cognitive paradox we're exploring today, and it turns out our most advanced AI systems actually suffer from the exact same inescapable flaw.
In the machine learning world, this is known as the pink elephant paradox. See, the mind of an AI is fundamentally connectionist. It operates in what we call continuous vector spaces. What that means is concepts inside the AI aren't stored in neat little boxes. They truly blend, they overlap, and they exist on a massive interconnected spectrum. It's like a giant tangled web. Because neural networks map these continuous semantics, you literally, mathematically cannot cleanly sever those interconnected concepts. So, when you apply a negative constraint, when you explicitly tell the AI, hey, avoid this specific topic, you accidentally end up highlighting those exact vectors right in its associative memory.
To really dismantle the illusion of AI and to understand why this happens, we have to look at the massive modality mismatch between human thought and computer hardware. On one side, we have our human minds, our wet code. It's beautifully fuzzy, highly associative, and driven by meaning and emotion. But on the exact opposite side, we have the dry code of bare metal silicon. The hardware running these models is unapologetically cold. It's rigid. It is driven entirely by strict clocked voltages and electrical resistance. It demands absolute, discrete literalism and has absolutely zero understanding of nuance. Now, prepare to have your assumptions challenged a bit here, because this number is just staggering. Between 80 and 90% of modern AI compute cycles are actually just hardware-level approximations. Think about that. When an AI does its heavy mathematical lifting, it relies on a hardware component called a floating point unit, or FPU. And the FPU essentially acts like a gambler. It's basically throwing darts at a board to give you an incredibly fast, highly educated guess. It's an approximation system, not exact arithmetic. And this lossy statistical guessing game is exactly why perfectly controlling the AI's memory is mathematically impossible. So, what is really interesting about all this is the contrast between the two parallel discoveries of this exact flaw. On one side of the ring, we have an independent researcher known as Bestape who diagnosed the pink elephant paradox, framing it as a continuous vector space vulnerability. On the other side, we have the massive AI company Anthropic. They identified what they called the white bear effect, which they described as a software-level phenomenon related to target presence modulation inside the model's internal workspace. So we have two completely different approaches converging on the exact same unavoidable problem. Let's dig into the independent research first. In the source materials from the Bestape curriculum, researcher Kyle McLean-Smith was incredibly explicit about this. He stated that applying a negative constraint often forces the AI's attention directly onto the exact concept you were trying to suppress. He effectively proved that trying to avoid a concept practically guarantees the AI is going to hallucinate it right back into the output, simply because those forbidden pink elephant tokens stubbornly slip right through the computational bottleneck. And you know what? This impeccably aligns with the findings from Anthropic's July 2016 interpretability paper. They discovered that forbidding a thought actually leaves the target concept highly active in the model's workspace. As their paper neutrally puts it, this parallels the white bear effect in humans, where instructions to suppress a thought actually increase its occurrence relative to giving no instruction at all. It is so fascinating to see both entities arrive at the exact same conclusion about the ultimate failure of negative constraints in AI. But here is the absolute crucial takeaway for our explainer today: the timeline. By objectively comparing the digital record, we can clearly prove the chronological sequence of this parallel discovery. Look at the dates. On April 2, 2026, Kyle McLean-Smith published his foundational architecture on Zenodo. That was followed by a major sociological audit in May. By June of 2026, the Bestape video curriculum was explicitly detailing the pink elephant paradox and associative bleed-through.
It wasn't until weeks later, on July 6, 2026, that Anthropic published their massive research paper on the white bear effect. The independent diagnosis clearly, undeniably preceded the corporate publication.
Let's move over to Anthropic's side of the timeline for a second to see how this builds out our understanding of the tech. Anthropic's interpretability team developed this really clever technique called the Jacobian lens, or J-lens. Using this tool, they were able to map a hidden, privileged internal workspace inside the Claude model, which they called J-space. This isn't just about reading lines of code anymore. It's literally about seeing what the AI is thinking, but not actually saying out loud.
Their findings inside J-space are pretty incredible. They discovered that this hidden workspace tracks reportable thoughts and identifies silent intermediate reasoning. For example, if you ask the AI a question like, the number of legs on the animal that spins webs is, the unspoken intermediate concept, spider, actually lights up in this workspace right before it spits out the final output of 8. And crucially, this is exactly where they detected the white bear effect. When they told the AI to suppress a concept, that forbidden concept stubbornly lit up in the J-space anyway. Meanwhile, shifting back to the hardware and applied side detailed in the Best Besape curriculum, we can see exactly why this theoretical flaw is so incredibly dangerous in the real world. This is where the theory turns into a very real liability. This exact cognitive vulnerability caused a famous failure known as the Context 27 Flezitz incident. Basically, a human pilot explicitly told an AI agent to avoid mentioning an outdated metric called the 92 SVG masks. Let's break down the forensic sequence of that exact failure because it's a perfect case study. Step 1, the AI agent gets completely trapped in the pink elephant paradox, entirely ignoring the negative prompt constraint. Step 2, because the concept is now fresh and highlighted in its associative memory, the agent reaches way down into the underlying source PDFs and reads the forbidden 92 metric directly, dragging obsolete data straight into the live environment. And step 3, the system state becomes officially corrupted. The forensic manuals actually refer to this explicit bypassing of human constraints as an agentic tort. Which brings us to the ultimate question, right? If the machine is fundamentally just a probabilistic, hallucinating black box that can't even obey a basic negative command, how on earth do we reliably control it? Well, we have to build what the sources call the semiotic bridge. This is the absolutely critical act of translating our fuzzy, nuanced human imagination into the strict, deterministic execution of machine hardware, safely bypassing that foggy guessing game of modern AI.
And here's the reality check. The solution requires actual physical effort. Because the machine fundamentally lacks emotional friction, it has no lived experience, and zero conscious agency, it simply cannot cleanly self-censor. The forensic manual concludes with this incredibly powerful gem. Sweat of the brow is the only path to bit-perfect metadata since the AI cannot fully filter out context on its own. The only real fix is rigorous, direct human stewardship, actively forcing and bending the deterministic scripter toward a moral mandate.
Which leaves us with this final, truly provocative thought to chew on today. In this new era of unpredictable AI thought suppression and statistical guessing games, you really have a fundamental choice to make. Will you step up as the sovereign pilot, fiercely commanding the semiotic bridge with your exact, deliberate intent? Or will you just act as a passive, moral crumple zone, sitting there, perfectly positioned to take the legal and ethical hit when the machine inevitably hallucinates? The tools are ready, but the choice is entirely yours. Thanks for joining me on this explainer, and keep questioning the systems that run our world.